get right into it. We hear the word shock thrown around all the time, right, to describe being surprised or maybe even scared. But in the world of medicine, shock means something entirely different and way, way more serious. Today, we're going to break down what it really is, a critical, life-threatening emergency. Now, that sounds incredibly dramatic, I know, but honestly, it's how medical experts view this condition. It's not a feeling, it's a physiological state where the body is literally on the brink, fighting to stay alive. It is a moment balanced on a knife's edge. So let's just get this straight from the get-go. The shock you feel from a surprise party, that's a psychological reaction. Medical shock, on the other hand, is a physical crisis. It's what happens when your circulatory system, that whole amazing network of veins and arteries delivering oxygen everywhere, starts to fail, big time. And this, right here, is the absolute core of the problem. Every single cell, every tissue, every organ in your body desperately needs a constant supply of oxygen to do its job. When that delivery system breaks down, the body starts to shut down. It's really that simple and that serious. And if you're wondering just how serious we're talking, well, the mortality rates for patients in shock are over 20%. It doesn't matter if it's from a bad infection, major blood loss, or a heart attack. This is a very dangerous condition. And that's exactly why spotting it and treating it fast is so critical. So what's actually going on inside the body when someone's in shock? To really get it, we've got to zoom in, way in, down to the cellular level. Think of it like the entire power grid for a city suddenly failing. It's this awful, cascading failure. First, you get the system failure. The circulatory system can't keep up. That leads straight to step 2, organ underperfusion. That's just a way of saying that vital organs like your brain and your kidneys aren't getting enough blood. And that brings us to the final critical stage. The cells themselves start to shut down. You know, when we get down to that microscopic level, there's one key player in all of this, the mitochondria. You probably remember these from biology class. They're the tiny little power plants inside every single one of your cells. They're the ones using up almost all the oxygen you breathe to create the energy that keeps you going. And this is just the perfect analogy for what they do in this situation. You know how miners used to carry canaries to warn them of toxic gas? Well, your mitochondria are just like that. They are the very first things in your body to feel the effects when oxygen levels start to drop. They're the body's earliest alarm system. So when those mitochondrial power plants are starved of oxygen, the cells get desperate. They switch to this sort of backup generator. But the problem is, this emergency process creates a nasty byproduct, lactic acid. For doctors, seeing high lactic acid levels in the blood is a massive red flag. It's a chemical scream for help, telling them the body's cells are suffocating. Okay, so if all this chaos is happening on the inside, how in the world do doctors and nurses spot it from the outside? Well, it's kind of like being a detective. You're searching for clues that point to this silent killer at work. Clinicians are trained to look for a whole combination of signs. A patient who just looks really sick or is acting confused. A heart that's racing, trying to compensate at over 100 beats per minute. Breathing that's quick and shallow. And, a big one, very low urine output. That's a huge sign the kidneys aren't getting enough blood flow. Now, you're probably thinking, wait a minute, I always thought shock was just really low blood pressure. It's a super common assumption, even in healthcare. But is that really the whole story? And the answer is a crucial no. This is one of the most important things to understand. See, your body is an incredible machine. In the early stages of shock, it can actually compensate. It'll squeeze blood vessels tighter to keep the blood pressure reading in the normal range, even while the cells are already starting to starve for oxygen. If you wait for the blood pressure to drop, you might already be too late. And that's exactly why diagnosing shock is all about connecting the dots. It's not about one single number. Doctors have to combine what they see in the physical exam, what they find in lab tests, like that rising lactic acid we talked about, and how well the organs are working, like that urine output, to really build the full picture. So once shock is identified, the clock is ticking. I mean, it is a flat-out race against time to pull the body back from the brink and get things back in balance. And here's the thing. While there are different types of shock, the main goal of treatment is always the same. Get oxygen back to the tissues, and do it fast. But how you do that completely depends on what caused the whole crisis in the first place. Let's look at 3 classic examples. In hemorrhagic shock, the problem is simple: blood loss.
So the fix is to stop the bleeding and replace the blood. Makes sense, right? Then you have septic shock. Here, a huge infection makes blood vessels leaky. The fix is to give fluids, antibiotics for the infection, and often drugs to tighten those vessels back up. Finally, there's cardiogenic shock. That's when the heart pump itself is failing. The fix there is to support the heart with medications or other interventions. See? 3 different problems, 3 very different targeted solutions.
All right, we've gone through a lot here, so let's boil it all down. What are the absolute key takeaways you need to remember about this incredibly complex condition? First, at its very core, shock is a cellular oxygen crisis. Second, and I really can't say this enough, it can happen even with a normal blood pressure reading. Third, recognizing it early, using all the clues we talked about, is probably the single biggest factor in survival. And finally, treatment has to be fast and it has to be aimed directly at the root cause. You know, understanding what shock truly is isn't just for doctors. It's about understanding how our bodies work under the most extreme stress, knowing it's more than a number on a cuff, and being aware of those subtle clues. It makes you realize what a true medical emergency looks like. It really is a race against time.